I'm doing strength of material previous year questions from the exams like GATE, Engineering Services and Civil Services. This is the I think 25th or 26th lecture for the strength of material previous year questions. Today we are going to see the questions of engineering services from the mechanical engineering. Okay, so those who are from civil background also, you can take advantage of this. And today we'll deal the questions of bending moment and shear force diagram. Okay, this is about myself. Let's see this engineering services question. Okay, so the first question, I think not first question. We have already completed some 20 questions. So if you have not watched, please watch those videos as well. Anyway, a simply supported beam has equal overhanging length and carries equal concentrated loads P at the end. The bending moment over the length between the supports is zero, is non-zero, constant, varies uniformly from one support to other, and fourth one is the maximum at the mid span. Okay, so as per the given question, they are saying simply supported beam has equal overhanging length and carries equal concentrated loads at the end. Okay, so this is the nothing but is the loading diagram. Okay, so they are asking the bending moment over the length between the supports. So they are asking what is the bending moment in between these supports. Okay, so this is nothing but the shear force diagram for this loading, and this is the bending moment diagram for this loading. Okay, how this is coming? Maybe soon I will start the strength of material complete lecture series. So there we will see more explanation way how to draw this SFD and BMD for all type of loading conditions. Okay, as of now you just remember for this kind of loading, this is the SFD shear force diagram, this is the bending moment diagram. Okay, so we can see here it is non-zero. Okay, it's non-zero, so it's non-zero constant. So the answer will be next question. Again, the bending moment diagram for the case shown below will be so this is the the bending moment, the loading diagram. So they're asking what is the BMD for this loading condition. So this is actually this kind of, if you have remembered the previous question, so from there itself you can get the idea of that. Okay, so this is not going to be the BMD. Okay, this is also not going to be the BMD, this also is not going to be the BMD. Okay, even if you are seeing for this, okay, so the answer will be A. So with the help of the previous question itself you can answer this question. Next question, which one of the following portions of the loading beam shown in given figure is subjected to pure bending? Okay, so they are asking actually for this loading which portion of beam, whether AB, BC, CD, DE or BD is in pure bending condition. Okay, so this is the question. So see, if you remember, if you see this portion, BD portion, okay, so this is actually nothing but it is in pure bending condition. Okay, so the answer is T. So the pure bending condition took place in the section between two weights. Okay, so you please remember this line. Pure bending takes place in the section between two weights. Okay, so where is two weights? B at B and D. So the answer is D. Okay. Next question. Constant bending moment over span L will occur. Okay, so they are asking, these four options is given. They are asking constant bending moment over span L will occur. Okay, so in which loading condition the constant bending will occur? Okay, see, again I am going to tell one thing. Okay, already I have mentioned many times. just wait for maybe 1 or 2 months. I will start all the theory part of this strength of material with long questions, like for conventional type of questions. So there, for each loading condition, I will draw the CFO diagram and bending moment diagram. Okay, so if you watch those videos, so these questions will be hello for you. Okay, you can easily solve this kind of question. So even if you don't know like how this is SFD and BMD is coming, don't worry, you please remember this question and directly the answer, because with these questions you will find the similar kind of problems in the exam. Okay, so you just wait for a few months. I will come up with the complete lecture series for all the mechanical engineering subject in this platform. Okay, so we'll see the BMD of where constant BMD occurs out of these four. It is actually this one is D. For this loading condition we'll get constant bending. It is nothing but it's pure bending they're asking. Okay, so the answer is D. It is nothing but it's the previous questions. Okay, you just go back to the previous questions, you'll find the answer of this question. Okay? In one of the questions they have plotted the bending moment for this D loading. Okay, loading for this option D. Next question, for this loading condition for the beam shown above figure, the elastic curve between support B and C. Okay, B and C, what type of the shape will be for this B and C? They're asking circle, parabola, ellipse and straight line. This will be actually parabola, so the answer is B. Next question. Okay, so this is the loading condition. They are asking SFD, shear force diagram for the beam. Okay, so what is the shear force diagram for this loading? Okay, so but is D. Okay, so for this kind of loading, okay, this is the SFD. Okay, again I will tell you again, don't worry, you please remember, as of now you remember this is the answer. Okay, I will do complete lecture series there. We'll see all kind of loading. For all kind of loading, what is the SFD? Okay, so as of now you just remember this is the answer. Because see why I'm saying this, if I'm going to start writing the plotting SFD and BMD for all loading condition, it will take a lot of time. Okay, even one question will take a lot of time, because we have to draw the equations, we have to write the equations, then we have to plot those equations, so it will take a lot of time. Those things we'll see separate. Okay, so this is previous year question, so what kind of questions came in the exam, that we should know that. Okay, so don't worry, all kind of explanation you'll get for these type of questions. Okay, next question again here. So this is the loading condition. Beam AB is hand supported at its end, is loaded by a couple. Okay, so there is a couple P into C. Okay, so they are asking as shown in figure, the magnitude or shear force at the section of beam. Okay, so they are asking this at this section, what is the magnitude of shear force. So what we have to do, actually we have to take moment about point B. This is the point B. Okay, so if F is the shearing force in section X, they are asking in this section what is the shear force. So let's say there is F shear force is acting in this section, so you take bending moment about this point P. Okay, write the equation and get that F. Okay, So what about, I mean, if you're taking a bending moment of, I mean, moment about this, so F into, what is the length? L plus L 2L. So F into 2L, and there is one more couple. This couple, it will be equal to this couple. Okay, so if you simplify, you'll get PC by 12. Okay, so the answer is PC by 12. So the answer is D. Okay. Next question. So they are asking a freely supported BEM at the end carries a central concentrated load and the maximum bending moment is M. If the same load uniformly distributed over the BEM length, then what is the maximum bending moment? Okay, so what is the maximum bending moment for? You can see the options. So see, this is the loading condition what they are saying. Okay, so this, so L, so here is acting is the W, so this side it will be L, W by 2. This is nothing but is the CL force diagram, and this is nothing but is the BMT. This is the BMT. 1 second. This is the 1 second. This is a problem. Okay, this is 1 second. Yes, this is nothing but is the BMT. So what is the bending moment? Bending moment for this standard expression is there. Bending moment is this. Okay, it is 4L by M. I mean 4L by 4. This is the it's standard equation. Okay, once we'll see this how to draw this SFD and BMD, there we'll find this equation. So it's nothing but WL by 4. Okay, since it is for so now you can see here for UDL. Okay, for UDL maximum bending moment is this. Okay, so we have to simplify this in terms of M. Okay, we have to simplify in terms of M. So if you simplify this like this, you'll get M by 2. So the answer is B. Okay, so instead of W, we have to simplify in terms of M. So here bending moment W L by 4 is what? M. So this value we have to put here, and we'll get M by 2. So that's why. Next question. Here also a simply supported BEM is subjected to distributed loading as shown in the diagram given below. What is the maximum shear force in the beam? Okay, so in this loading condition they are asking what is the maximum shear force. Okay, so again here also the total load. What is total load? Like the area of this, so it is W half of length into width, so it is WL by 4. The shear force, it is actually this is the total shear force, which is WL by 4 minus 1 by 2 WL by 4 into X. Okay, like we will take one is small at a distance X. What is the shear force? So it will be this. So the final expression for this, let's say this is XX. In this XX, what is the shear force? So WL by 4 minus WX square by 2. So what is the maximum at X is equal to 0? It is WL by 4. Okay, so the answer will be D. Okay, since here it should be actually WL by 4, so the closest is WL by 6. So the answer will consider D. It is actually WL by 4. But since WL by 4 is not given in the option, so we have to consider WL by 6. Next question. A beam having uniform cross section carries a uniformly distributed load of intensity Q per unit length over its entire span, and its mid-span deflection is del. The value of mid-span deflection of the same beam when the same load is distributed with intensity vary from 2Q length at one end to 0 at the other end. Okay, so they are asking the value of deflection, okay, mid-span deflection of the same beam when the same load is distributed over intensity of 2Q. Okay, so when intensity is 2K, then what is the value of deflection with the mid span? So this is nothing but it is actually D. Okay, it will be del only. So the answer is D. Okay, so this was the end of few questions of engineering services from the SFD BMD. We'll see some more questions.